Of course, Mrs. Sabat, why would you start our week out on the super spicy warm up? It just happened. It wasn't planned. But we'll see. We'll see. You've done a spicy one like this before, so maybe it won't be as bad this time. Okay, so solve by square roots. That means we have to get the x squared by itself plus 2. You're already starting to see that it's gross. Okay, let me just pause there. Any questions at the moment? Everybody good with adding 2, dividing by 3, and then realizing in deep, deep fear that it's gross? Okay, next. Okay, the first thing we're going to do, so we square root both sides, that's fine. We're going to not forget the plus or minus, even though it's Monday morning. Going to remember it. Look at us go. Okay. This is not a final answer, not acceptable at all. There's 2 issues with it that we need to fix. One of them is there's a negative under the square root, which my math 1 kids are so excited to still be able to write no solution to. And I keep telling them that those days are ending for them. But for now, they still get to do that. And there's also a root in the denominator. Do you guys see that the square root of 3 is in the denominator? Even though it's like the whole thing, square root of 3 is in the denominator. So we're going to fix it in 2 steps. First thing we're going to do is fix the negative. That's relatively easy. And then we're going to fix the problem of the root 3 in the denominator by what's called rationalizing the denominator, multiplying by a giant 1 to fix it. Eleven times 3 is 33. And then what's the square root of 3 times the square root of 3? 3. Now it's done. Now, technically, you'd have to check to see if 33 has any perfect squares in it that you could simplify, but it doesn't. It's just 11 and 3. That's a fun one. Okay. Them are easier. We're smooth sailing now. Okay, so now we have the backwards of this guy. We have to take this guy and put it backwards into the fraction. So we have 6v in parentheses. Okay, the question is it 5/3 or 3/5? 5/3. That's it. That problem's done. It's excelente. Okay, flip to number 10 and 12, please. Teams. Okay. Now we're going to do the same thing we did over here. We're going to change it to radical form, and then we're going to simplify. So 216x to the 9 goes underneath a root. What type of root is it? Cube root, because of the 3. And then we're going to square it. So the first thing we're going to do is take the cube root of 216x to the 9, and then we're going to square that. The cube root of 216, this is 6 times 6 times 6, I believe. And x to the 9 is x cubed times x cubed times x cubed. So the cube root of 216x to the 9 is 6x cubed. squared. Do you see where I got the 6x cubed from? See how I showed my work there with my little chicken feet branchies? Okay, and then 6x cubed squared is 36x to the 6. If you want to do this math one style, you can make little dealios like that to help you. Okay, last one. Exponential. Start at 3. Multiplier is times 2 each time. 3 times 2 is 6. Times 2 is 12. Times 2 is 24. Oh, I can't fit that last one on the graph. It's fine. It's fine. I'll just do 3 points. Okay, so 0, 3, 1, 6, 2, 12. Okay, come along the x-axis. That's going to be the asymptote here. And voila. Mrs. Talbot, you barely went through any of the points. I know. I got 2 more shots at it today, though. 4th period or 5th period that might look better or worse. We don't know. Okay, now can you flip to the weekend homework, please, which was the chapter quiz review? Is there anything you'd like to discuss from this before we move on? Yes.
How do you do number 1?
Okay, well, first you get your notebook out and you flip to number 2-13. If you could find that for me, please. 2-13. Look at this, I can sort of fit it on, okay. Do you see this part of 2-13? Where it says plug in the vertex and a point? Okay, so this is your vertex, H, K. And this is your point, X, Y. And then you do this. For the part you need to memorize is this part. Okay, so Connor, all right, tell me what number is Y? 26 equals A. What number is X? Beautiful. Okay, now really quick here, you see how this is minus and this is minus? So I'm going to put plus 7 squared plus 8. If you guys want to show your work, you can put minus -7, but then your next step should be to make that plus 7. You can show that or not. It's up to you. But are you guys okay with the plus 7? Okay. All right, now let's look here. Here's my notes. Okay, so I had the formula, then I plugged it in. Then what did I do next? I undid K, right? Okay, so I'm going to -8 okay. What is -10 plus 7? Beautiful. And what is -3 times -3? 9. Okay, now this is one of those places where sweet, sweet children will drop the mic and walk away, but this is not done. We'd be very sad for them if they left it like this. This is not the end. We have to rewrite it. We have to put the equation in. So 2x plus 7 squared plus 8. Somebody check the answer key, make sure I did it right. I did? Sweet. On a Monday morning and everything? Better? Yes. So this is asking you to write the equation. The equation is something that you can solve all points for, not just this one. So you want X and Y to be letters, and you only want A, H, and K to be your numbers. If you plug, so we want to be able to plug in anything for X and find what the point would be. If we put -10 there, then there's nothing, there's no variables, so we couldn't find the other points. So maybe when you're thinking about this, you want to make sure you're only plugging those 3 in at the very end and leaving X and Y. All right, now you can try number 2 on your own. Not at this moment, but just sometime. Okay. All right, you guys, I will be stamping this tomorrow toward the end of the period, so just so you know. All right, packets are done. Packets can go away. I'm hoping, wait, pause, hold on. I'm hoping 3 and 4 and then the Traeger, okay? I get needing to do this one more time for sure, but this other stuff should be okay. If not, just see me separately. Okay, you do not need your notebook today at all. So you don't need to get that out either. What you need is this blue guy. This is what I am going to use today. I'm going to use this blue guy. I'm going to use a black pen, a red pen, and a straight edge. Okay. You may have noticed the lengthiness of this blue thing here. Did you notice that it's kind of lengthy? We're only going to do 5 entries today. We're doing 5 entries today, 2 tomorrow, and then 2 on a completely different day of the chapter. It's not as bad as it looks, I promise. To be honest with you, you guys already know quite a lot of this, so we're just summarizing it onto an organizer that's going to be really handy for you to use. Homework tonight is 30, 31, 33, and 36, and whatever of that quiz 2 review you didn't do. And this is my joke. It says teachers giving their students the look when they misbehave. There's the look right there. That's the one I'm going for every time. Tilted head ostrich. Is that an ostrich? I've been chased by an ostrich before. Not even joking. At Safari West in Marin. Anybody have been to Safari West? Yeah, they have ostriches there. And you go in like this Jeep-like thing, and they're not friendly. There are no non-friendlies. They don't want you there, the ostriches. They want you to leave pronto. Anyway, now if you spend the night there, which I don't recommend, the flamingos will yell all night long and you'll get no sleep. So, anyway. Birthday parties when my kids were little. Oh. Okay. So we're going to do, as I said, 5 entries of this today. 2 tomorrow. Miss Rice got me that as a wedding gift last year when I got married because I was super excited about my new name. Isn't she sweet? I love her. Okay, so we're gonna start with the the one you're most familiar with, this family name is quadratics. And this is the parent equation. So this is the one that has no transformations in it whatsoever. And the general equation, we just talked about this. It's like you guys knew what was coming. Is that? The locator point is the vertex for a parabola. You guys all agree that the most important point on the parabola is a vertex. It's kind of how you find everything else. And that point is HK. And there are no asymptotes for quadratics. Does anybody know the two types of functions that have asymptotes that we've studied so far? There's only two. Rational and we just did one in the warm-ups. Exponential, yeah. He's the best. Okay, now end behavior. This is something we haven't talked about yet. So what we're going to do is we're going to skip the end behavior box and we're going to come down and make a sketch of it because the sketch will help us make the end behavior. And so we're going to sketch the very basic parabola, this guy, the parent equation, y equals x squared. We're not going to do coordinate points. We're not going to make it perfect. We just know that it goes to the origin and it looks something like this. Okay, I want to pause real quick. Any questions so far? Anything not make sense about your regular old parabola? You guys know where the vertex is and what that looks like? Right there. Okay, now we're going to talk about the end behavior. This is your first time probably ever talking about end behavior. And this is fancy notation right here. So this is saying as x goes toward negative infinity. I want you to think about the x-axis. I'm just going to put a little x here. We're not going to do this every time because I just need you to get what I'm saying for if you notice it's the same every time. As x goes toward negative infinity, that means I'm moving this way. Would you guys all agree that going this way is toward negative infinity? Okay, so above this, we're going to write left. It really helps our brains to turn these symbols into directions. So as x goes left, this is saying, what does y do? And so we're going to look at the arrow, which way it's going. Our arrow is going up. So we say positive infinity. So this is saying as x goes to the left, y goes up. As x goes to the left, y goes up. Okay, the bottom one says as x goes to positive infinity, that's toward the right. So toward the right, is it going up or down? My arrow, up. Does anyone see a flaw in my logic? I wrote these infinities close to that arrow on purpose. Anybody see a flaw? Are they always up and up? What do you guys know about parabolas? Okay, hold that thought. On this graph, we're going to graph two parabolas. That's why I'm going to use two colors. This is the parent graph. We're also going to graph a transformed one. And I'm going to write that equation down here. Y equals -2 x minus 3 squared plus 4. I'm going to put it in red. I'm going to graph this one in red, and then you guys will be able to see my end behavior situation. Anybody already see it? What's going to happen with this guy, this parabola? There's a negative in the front. Yeah, it's going to go down, down, right? Okay, so we have to make two situations for our end behavior. For this, what I want you to do first is locate for me whatever you think the 0.34 is. We're going to use this 0.34. We're going to try to keep it consistent through all of our graphs. By the way, they won't all take this long, I promise. I just need to talk about some stuff for the first one here a little longer. Okay, so there's my vertex 3, 4. I also notice it's reflected across the x-axis and vertically stretched by a factor of 2, which means I need it to go down, but I need to show that it's steeper than my original. It's not perfect, and I don't know that it goes through 0, 0 either. I'm just winging it. It's okay. But can you guys get from this picture that it's shifted right 3, up 4, reflected across the x-axis and vertically stretched by a factor of 2, so 2 times skinnier. Okay, so notice here, both of my end behaviors, my ends of my arrows are going down. So this requires us to go back up here and make another entry. These are for a positive A value. And then for a negative A value, they're both going to be downward arrows. Okay, now the domain and range, you're going to love this. You're going to love not doing this, but you're going to love having this, because when you have a parabola, you could just flip to this and figure out the domain and range. The domain is all real numbers no matter what. These parabolas go forever to the left and right, no matter what the transformations. The range, however, there's 2 of them. I feel as though maybe I should scooch that a little closer. Y is greater than or equal to k for a positive A, or y is less than or equal to k for a negative A. Now you don't even have to think about domain and range. You could just pick up your little paper and be like, oh, just plug in k. All right. 1 down, 4 to go. I promise they'll go faster than this. Double, triple promise. Quadruple promise. Okay, moving to the next one. You probably have never seen one of these before. Maybe you have, I don't know. These are called cubics. Now use your super powers of intuition and tell me the one change between the general equation of quadratics and cubics. They're exactly the same except for one little thing. What is it? Goes from squared to cubed. Y equals a x minus h cubed plus k. Exactly the same equation. It's just cubed. So I need to show you what a cubed looks like. Has anybody seen a cubed before? You wouldn't just sit like, mess around with your calculator and this is how that has some glare issues. Camera, I hate the, not really. I actually can't live without it, so I don't know. Okay, anyway, it looks like this. So it goes up and then it flattens out and then goes up again. So come down here and you do a sketch. It goes up from the bottom, flattens out at the origin, and then goes up again. That's what a cube looks like. Now, why does a cube look like this? Well, first of all, can you tell that it's steeper than a parabola? That makes sense because you're cubing numbers. But what is the cube of a negative? Is it negative or positive? A negative. So that's why this side is going down, because the cube of a negative is negative. Anyway, okay. Now, the locator point, this is not a vertex. This is called an inflection point. Inflection point is where it's going to flatten in the middle. So it goes up really steep and then it goes slow, 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 and then goes up steep again. But that inflection point is still HK. It's just not a vertex. And it's our lucky day. There are no asymptotes. Okay. All right, now let's look at the end behavior. So this top line, x goes to negative infinity, that's the left. So go to the origin with your pencil, go to the left. What is my left arrow doing? Going down. And what is my right arrow doing? Going up. Okay, now this is for a positive A value. What in your discriminating mind do you think is going to happen when we have a negative A value? Yeah, it's going to be positive on this side and negative on that side. Let's see if I can get it to show up. Oh my gosh. Glare. Oh, that's really good right there. Don't touch anything. Okay, so that inflection point shifted right 3 up 4, and it's coming down in the opposite direction 2 times steeper. Hard for us to make the steeper, but that's okay. We'll give it our best go. So try to locate for me that 0.34. Just try to make it exactly the same spot. Then come down from here, flatten. This really shouldn't be going straight down. It should be more very subtly like that. Now the left arrow is positive going up and the right arrow is going down. Just what we did with our, that's what we guessed up here. And this is my favorite part about cubics. The domain is all reals and the range is all reals, no matter what you do to it. 2 down, 3 to go. See how much faster that one went though? Okay. Next one. These are called absolute value graphs. Have you guys graphed these at all? Anybody remember what shape they make? Yeah. It's a V, exactly. Okay, so what we do for our equation, we still have A in the front. Instead of having parentheses, you have X minus H in absolute value and then plus K. No exponents or anything. The parentheses just become absolute values. And this one is back to having a vertex, which is the bottom or top point of the V. And no asymptotes. Okay, now scroll down here. Your regular absolute value graph is going to have a slope of 1, so you want it to look like it's 45 degrees. Splitting the first quadrant as equally as you possibly can. That's kind of okay. They're supposed to be even, but it's a sketch. Okay, my left arrow, is it going up or down? Up. My right arrow. And what do you suspect is going to happen with a negative A value? They're both going to go down. Beautiful. Okay, so locate for me that coordinate again, 3, 4. I'm going to use that one every time. Try to make it as best you can in the same spot each time. And then we're making it go down, but also it's got the A value of 2, so we need to make it 2 times steeper, appear 2 times steeper. Pause for a sec, make sure that you've got all 6 of the graphs and all 3 of the equations at the bottom. And I'm hoping that somebody will notice that the domain and range of a parabola is exactly the same as a domain and range of an absolute value. Can you kind of see that they're exactly the same spots? Like this one's above the x-axis. This one's above the x-axis. Anyway, they're exactly the same. So you can just copy over the domain and range section from your parabola. That one only took us 3 minutes. Click and find the exponentials. Exponential is probably going to be the hardest one. And then square root will go back to being easy. Okay, so in math one, your graph for exponentials was a b to the x. We just did that in our warm-ups too. The general equation though is actually a little bit more wild. You hadn't learned everything yet at that point, so we're going to put all of that together. The general equation is y equals a, b is for base, and then the x minus h is in the parentheses plus k. I meant the exponent. So b's in the parentheses, and you don't actually even need parentheses. You could just put a times here if you wanted to. But the x minus h is usually in the parentheses for us. This time it's up in the exponent. Okay. The locator point is a little bit more challenging for this because HK is on the asymptote. We can't have a locator point being on the asymptote because that's not actually on the graph itself. So what we do is we take HK and then we add one growth value to it to get back onto the graph. I know this is really weird. This is definitely the weirdest one of today. And then there is an asymptote. It's horizontal at y equals k. Just want to really quickly, before I move on, to make sure you have those first 4 boxes right there. Before I move on, I want to just go back to these real quick. We did these 2 warm-ups. This is what we're talking about in this particular problem. Can you guys pretend that there's a +0 here? That's why the asymptote is the x-axis at 0. And there's a +0 here. That's why your asymptote is at 0. If I had +1, it would be shifted up 1, and the asymptote would be at 1. Just saying. Just to help your brain. Okay. Before we do end behavior, let's sketch the guy down here. So we know for the regular one, b to the x, a b to the x, you're going to come along the asymptote, and then it's going to go up like that. Which is exactly why we put those warm-ups in when we did, just saying. And then I want you guys to come along the x-axis and make an attempt as best you can with whatever writing utensil you have to dash that to show the asymptote. And that asymptote is going to be y equals k. Whatever that number is on the end, for the parent graph, it's 0. Okay, this is a really challenging end behavior. Let's skip the top one. What's the right arrow doing? Let's just talk about the easy one. What's the right arrow doing? Is it going positive infinity or negative infinity? Positive, right? Okay, so we know this part, we can fill this in. The right arrow is going to positive infinity. Next question, super advanced question. What is the left arrow approaching? Yes, but more in general in this problem, or in any problem. It happens to be 0 for the parent graph. What's it approaching for all of them? The asymptote, which is what letter? K. Okay, so if this were to be this one 0, in this case, it's approaching 0. But if this were to be shifted up 4, which you'll see in a second, or something like that, it would be approaching 4. So hold that thought. Because we're writing this in general, we want to write these things in general. Okay, before we move on to sketching the other one over top, what's the domain of this thing? Is it going forever left? There's an arrow to the left. Is it going forever left? Is it going forever right? Yes, okay. Now this one is a positive A value. What's the range? This is hard. Y is greater than K. And make sure not to put the or equal to, because it's an asymptote, it's never going to touch. Perfect. Okay, now let's draw the transformed one. And there's a confession I need to make to you on this particular one. Right here, I'll go back to the bottom, but I have a number to plug in for A. I have a number to plug in for X, for H. I have a number to plug in for K, but B needs to have a number in it. So just for this problem, I'm going to just declare, and I'm not going to do it for any of the other ones. I'm going to declare that B is 2 because it's the easiest. Okay, what I want you guys to do is find me that 0.34. That same 3, 4 that you found me the whole time. And then I want you to draw that asymptote in at 4. Do you guys see how 3, 4 is on the asymptote? So it can't be our locator point, because our graph is never going to touch the asymptote. Okay, so that's fine. What we need to do is sketch it, and it's going to come, so it's -2. It's going to come this way still, and it's going to go down like this. Terrible, terrible, terrible. I should have just stopped it here. Okay, now let's fill in the other stuff. So in my new graph, the red one, what's the left arrow approaching? The asymptote still. This is still K. But the right arrow is flipped downward. And the range is flipped downward. Right, we have one more. And the next one's going to be so much easier than the one we just did. These are the fancy name is radicals. Sometimes we call them square root graphs. You guys did these on your poster. Second week of school, first week of school. Still y equals a. And then the parentheses turn into a root plus k. The locator point on this is an end point. No asymptotes. Oh, we're thrilled. Asymptotes are a pain. Oh no, sorry. Rational function, which I see is the first one for tomorrow. Do you think I offended him? I hope not. Okay, so let's go down and draw our very basic square root graph. If you remember, it was like a dot, and then it was like a half parabola on its side like that. Okay, so anyone kind of worried about the situation with the left arrow? There is no left arrow. There is no left end behavior. That's great. However, the right arrow appears to be going up. And the domain and range, x is greater than or equal to h. So this way, always. The range has two possibilities. Y is greater than or equal to k. Or something else. Almost done. Okay, find me that coordinate 3, 4 again. Okay, and because it's got a negative a value, it's going to go down. But because it has a negative 2a value, it's going to go down steeper than before. Okay, and so that means that my right arrow is going to be going down, which is not shocking. We know that they flip. And my range is going to be going down, which is not shocking because we know that they flip. All I have left to do is write the equation. And I'm done.